Okay, so today in this video, I'm going to tell you about introduction of 142,857. Now, this number is practically useful in this. It's a cyclic number. In my last video of 142,857, the video was not quite right. So let me tell you about the introduction. There are some fun things you can do. So let's choose the number itself, which is 1, 4, 2, 8, 5, and 7. So 1, 4, 2, 8, and 5, 7. Now suppose this is the first group, this is the second group. So here, add the first digit of the first group. Add the first digit of the first group and the second digit of the first group to equal the second digit of the third group. I meant to say the second digit of the second group. Then the next permutation is multiply the second digit of the first group and the third digit of the first group to equal the first digit of the second group. And finally, the last one is add all the digits of the first group to equal the last digit of the second group. Yeah, this was very short. So if you liked this video, I'll see you next time. Bye bye. I know what is the thing of 142,857. It has a lot of properties that I'm going to tell you in next videos of mine. So let me tell you about this interesting fact about 142,857 re-adding up. So I want to start with your favorite number. Just don't choose a number between 1 to 7. Just choose a number other than them. So if you said 16, then it is 2285712. So 2 plus 285,712 is 285,714. So here is the property that this number 142,857 does. Now here's a table that you want to remember. So 142,857, there should be always matched with 8, 15, 22, 29, then 36, 43, 50, and so on. And for 285,714, here's the here's the 9, 16, 23, 30, 37, 44, 51, and so on. And for 428,571, there's 10, 17, 24, 31, 38, 45, 52, and so on. Then for 571,428, there's 11, 18, 25, 32, 39, 46, 53, and so on. And for 714,285, there's 12, 19, 26, 33, 40, 47, 54, and so on. And then for 857,142, there's always 13, 20, 27, 34, 41, then 48, 55, and so on. So this is a table that you should always remember. So there is a book that is given. So multiply 142,857 by a really large number and then see what happens next. So you have to check how does this happen. Now refer back to the table. So I have given you an example. For example, I showed you what is 142,857. That was the 285,714 example, which was just like how to re-add up like other cyclic numbers. First let me stick with this cyclic number. So here is the cyclic number. So if I say that this number now if I say that this number only adds 142,857 is just re-adding again because of a number 999,999. This is the only multiple of 142,857, which is re-adding up. So there is just what I wanted to do. Now if I add this by a particular number that is 428,571, then the answer is 1,428,570. See, this is how it adds. And this is equal to 428,571. The reason why 142,857's multiples are adding up, because of this number 999,999. For a cyclic number that is only made up of, for a cyclic number whose multiple is made up of only 9s, it re-adds up again. So if you liked this video, don't forget to like and subscribe. Bye-bye. Okay, so let me tell you about an interesting chapter called Subtracting Squares. Now here I found this something. Well, it doesn't work with either 142,857, 285,714, and 428,571. It doesn't work with these numbers. The reason why is the fourth digit compares with the first digit. For example, the fourth digit is bigger than the first digit. So the answer would be negative for these numbers. Let me start. If this works with a number called 571,428, then I have to use their squares too. Then the answer is 142,857 itself. Yeah, this is why they use 142,857 as a number like this. Then the next number is 714,285. So 714 squared minus 285 squared. That's 428,571. And the next number is 857,142. That is equal to 714,285. Yeah, this is how it subtracts the squares. But it doesn't work with 999,999 because the answer will be 0 itself. And I don't want this. So let me just start the topic. So here is the number. Now what should I do with this number? If I chose even a bigger number, now suppose I chose a smaller number. Now that number is a 285 minus, now it's 285 squared minus 714 squared. Now the answer would be negative as what would happen? What would happen after subtracting even a single square? Then the next number, that because this number 509,796 is bigger than 81,225. So this number doesn't work. And the answer would be negative 428,571. So which means with the number 285,714, it also doesn't work with 142,857 and 428,571. Now let's choose a number with 7 digits. And how is it possible to do? So here's 1,142 squared minus 856 squared. So here's the opposite. So the answer is 571,428. Yeah, this is why they say squares. Now, if you check what's happening with this squares thingy, well, basically, if 142,857 is the n, then it doesn't work with n, 2n, and 3n. These three numbers are just false, and it works, and this only works with bigger numbers. Now, suppose if I did 142 squared minus 856 squared, which means 20,164 minus 732,736. But this is not possible because the answer would also be negative. So this is why for a 7-digit number, it shouldn't be divided into 3. For if an 8-digit number is there, divide the first group into 5, then the second group into 3, and if there's a 9-digit number, then divide the first group into 6, and then the other group should have 3, and so on. So I thought of making this video as a dial thing for me. So if you like this video, don't forget to like and subscribe. Bye bye. You remember 20,408.142857. That's 142,857 divided by 7. Yeah, that's 20,408 divided by, no, not. So let me just start the chapter. So here I found there's something. On my calculator, I checked out that 142,857 divided by 7, I found that this number is equal to 20,408.142857 and so on. So here, what do you mean by this number? Yeah, but this number 142,857 keeps repeating infinitely, but it doesn't work with 999,999. But slowly this number is getting to its multiples. For example, if 285,714, this would become 40,816.285,714. And if 428,571 divided by 7, this is 61,224.42857. Then for 571,428 divided by 7, this is equal to 81,632.57142. Ding 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 ding. Then for 714,285, the answer is 102,040.714285. Ding 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 ding. And then for 857,142, the answer is 122,448.857,142. Ding 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 ding. So here I found how does this work with its multiples. But for 999,999, it doesn't work. Because if you do this, then the answer would be 142,857 itself. The answer can't be 142,856.99999999999999999 and so on. So basically, I heard about this number. This number is called 200044897959183673446938775551. Multiply this number by 7 and you will get 142,857, and it has 6 copies of itself. Yeah. So here, if you divide, so now we know what is the first copy divided by 7. No. We know what is 142,857. That's the main number. But I have to do about its copies. So the first copy. So this is the first copy divided by 7. That is equal to 20408163265.28571 and so on. Here, this number here, this is a multiple of 142,857. But since this is not the main number, now I have to do the second copy. So here's the second copy. The second copy divided by 7. That is equal to 20408163265306122.42857. Ding 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 ding. So this is the second copy divided by 7. Now here comes the third copy. So the third copy here is, now divide this number by 7 and you will get 204081632653066124489. So 8979 point. So here 8979.571428 and so on. So this pattern keeps repeating 142,857's multiples. And here comes the fourth copy. And now divide by 7. This is equal to 20408163265391836.714285 and so on. And now here comes the fifth copy. So the fifth copy is, and now divide by 7 and you get 2040816326539183673. So here's the next copy, 2040816326530612244897959385714 and so on. And now the sixth and very last copy divided by 7. So here's the sixth and very last copy divided by 7. This is what I knew. 20408163265306122448938775551. So if you liked about this chapter of 142,857 and its copies. Don't forget to like and subscribe. Bye bye. I know that 1 divided by 7 is 0.142857 and so on. But what is the property of this thing? This is called how 142,857 and its multiples appear in reciprocals. But for this, I'm going to name it rogue 142,857. So such decimals like these 0.071428 I'm going to add a line over it so that it recurs, because this is a recurring decimal. And when it comes to 1 divided by 21, this is 0.047619 and so on. But this uses different digits. So such numbers like these are called rogue rogue decimals. I'm going to name them like this. And 1 divided by 28 is 0.03571428. So here I'm going to, and over 1 divided by 35, that's 0.02855714. And on 1 over 56, that's 0.01785714. But over this thing, it doesn't work with 1 divided by 63. If this only, so I'm choosing this only for this thing about how 142,857 and its multiples appear in reciprocals. Now let's check what is happening. Now if I do 1 divided by 77, that's 0.012987 0.12987. So this is what happens after you take a number. But this is, so 1 divided by 77, yeah, so 12,987 is just a factor of 142,857. Thus, it is not a multiple of 142,857. Well, so how do these appear in 142,857's multiples? Well, there is one way. There's an article on Wikipedia. You can just find it. And if you want to check that, now if you do 1 divided by 70, that's 0.014287. This is the same thing I'm doing with the numbers. So I found this in Wikipedia and I thought of making this video. So let's just start. So today in this video I'm going to tell you about how 142,857 and its multiples appear in reciprocals. So as you can see, such fractions, such numbers as 1 divided by 21, 1 divided by 42, 1 divided by 49, then 1 divided by 63, 1 divided by 77, then 1 divided by 84, These all fractions are known as rogue decimals. I'm naming them. So these numbers do not have even a single 142,857 in their decimal expansion. So 1 divided by 21 only contains 47,619. This contains 238095. And also I'm sending you the reciprocals of these numbers in the description. So let's just start. And also 1 divided by 98. And these type of fractions are just known as you think these are unit fractions, but despite these, we know why do not they have a single 142,857 in their decimal expansion, especially 1 divided by 49. That is the number that is the decimal expansion of that number I have shown you in the last video. 2040816322653061224489795918373551. Yeah, this number I have shown you in the last video. So such fractions. So 1 divided by 21 only contains 47619. 1 divided by 42 contains 238095. Then 1 divided by 63 contains 15873. Then 1 divided by 77 contains 12987. 1 divided by 84 only contains a 190476. Then 1 divided by 91 contains 10989. And 1 divided by 98, the most largest of all, contains 10, 20, 40, 89, 79, 5, 9, 1, 8, 3, 6, 7, 3, 4, 6, 9, 3, 8, 7, 7, 5, 5. Even though there are more fractions like these that I'll send you in the description. So if you like this video, don't forget to like and subscribe. Bye bye. This number is 142,857 cubed. Now this is a very large number. So divide this into the groups of 6. So the first group will have 696,793 plus 443,148 plus 2,915. The answer is 1,142,856. So this is the answer to this problem. So if we find out what is wrong with this thing, so this is 142,857 cube. I think it works with its fourth power too. You can just find oddities by looking at the digits themselves. So I figure out what is this number. So in this book, they have given an article, which is you can find oddities just by looking at the digits themselves. So right now they have given a very huge number. So this huge number is called, Oops. And also, I understand this thing doesn't work with its cube. So let me start this thing. So the oddities are, this is 142,857 square. Now I have already explained this chapter. So I have already explained this in chapter 2. So if you want to check the video of chapter 2, go watch it out. The link is in the description below. Even though you can just find oddities by using the digits themselves, by looking at the digits themselves. First things first, we have to use 142, and then the next thing is 857. Now check it out. So I divided this into groups. This is what I told you in chapter 1. So the link is also in the description below. Go watch it. So I have already covered a few topics about this 142,857. So here are some oddities. So 142 here. And 857. So I've already covered this. 1 plus 4 is 5. 4 times 2 is 8. Then 1 plus 4 plus 2 is 7. But now there is a new oddity coming here, which is 2 plus 5 is equal to 7. So here are the few oddities. Even though 142,857 is well impressed by 857,143. By now, I'm going to tell this number in the next video. So 142,857, this number can be divided into two groups. So now multiply 142,857 by a really big number, and that equals what? Yeah, this number is also like 142,857's cube. So now divide this in groups of 6, which is 48,218 plus 900. No, plus. So next is 90,000. So the next number is 90,027, and the next one is 4,612. Now, what does this equal? 1,142,856. Now, no resemblance to this, but divide this in groups of 6, and you will get 142,857 back again. So what is wrong with this number? I finally want to know this thing. Also, if you multiply this number by an 8-digit number, it also works. By a 9-digit number, it works. By a 10-digit number, by a 12-digit number. So here it works with numbers which are divided in groups of 6. It re-adds up with smaller numbers, but divides in groups of 6 in when it is multiplied by larger numbers. So if you like this video, don't forget to like and subscribe. Bye bye. So here's a proof about 142,857. So in this chapter, I'm not going to do about 142,857 and 285,714. But these two numbers are practically useless. So in this chapter, I'm going to tell you about the 3x plus 1 proof of 142,857. So let's start with the chapter. So if 428,571. So let's have a good start with it. Now multiply it by 3 and add 1. That is 1,285,714. So basically, if that number has a 1, let's start it. So if that number has a 2, in its decimal expansion, increase that number by 1. So it's 714,286 times 3 plus 1, which is equal to 2,142,859. So make this 2 negative and add this to become 142,857. So this is the 3x plus 1 proof of 142,857. So what do you mean of 3x plus 1? From 3x plus 1, you remember about the Collat's conjecture, right? But for numbers which have a 1, multiply them by 3. So I did this with if that number has a 1, then increase that number by 0.5, and now multiply it by 3 and add 1, which is equal to 1,285,715.5. So now just cut over the portion of this 5. Just cut over the portion of this 0.5, make the 1 negative, and then add 2 so that you can make 285,714. Yeah, this also works with 571,428. So let's give it a running start. Now this number starts with a 1, so increase that number by 0.5. Now multiply it by 3 and add 1 to get 1,714,286.5. Just avoid this 0.5 portion over here. Now take this and it will become 714,285. So even still, this also works with if that number has a 3 on its start, increase that number by 1.5. For example, 1,285,714.5 times 3 plus 1. Now what does it equal? 128,514, 3857,143.5. Yeah, this must be, but sometimes, but obviously doesn't work, because if you take the upper portion and no, this will become 857,140. I know this doesn't work, but I said this for fun. So let me just start this chapter. So this number 142,857 is really special here, as it is a number which is a very cyclic though. So let me tell you what is the proof of it. So the proof here is how does this happen? Now sometimes I use this. Now this can also work with the multiples of 47,619. So 809,523 times 3 plus 1, which is 2,428,570. But no, I said it wouldn't work. Increase that number by 1. Increase that number by 1 and times 3 plus 1 is a 2,428,573. Now make this 2 negative, then this will become 428,571. So if you liked this video, don't forget to like and subscribe. Bye bye. So here's a number 7 and the number 143. So what is the relation between them? So here's a statement. When you multiply both of them, why do they equal 1001? So well, this is the problem. Okay, so take any number, multiply it by a 7. Okay, take any 3-digit number, 2-digit number, or even a single-digit number. So what did you say? 815. Now what you have to do is 7 times 815 is equal to 5,705. So what I have to do is copy the 705, and what I have to do is 143 times 705. That is equal to 100,815. Yeah, this is the reason. So here is the problem I need to solve. So here once you make that number negative, for example 5 and 705. Okay, make the 5 negative, so this will become minus 5, and now add 705 so that this can become 700, a multiple of 7. And what is this? Minus 100 plus 815 is equal to 715. So This cannot be possible without the product of 7 and 143, which is 1001. Minus 5. Okay, so with this, minus 5 and 705 equal 700. And minus 100 plus 815 equals 715. So for 7, the answers will be 7, 14, 21, 28, and all the way up to 994. And then back to 0 is 143, which is negative 1 plus 1. And for 143, it's only possible because it is 143, 286, 429, 572, 715, 858, and back to 0 again. So this is the relation between 7 and 143. Okay, so what I had to show you was an equation. So 7 times 1 plus 3 is 10, and now 7 times 14 plus 2 is 100, and now 7 times 142 plus 6 is 1000, and 7 times 1428 plus 4 equals 10,000. And now 7 times 14285 plus 5 is equal to 100,000. And now 7 times 142,856 plus 4. No. 7 times 142,857 plus 1 is equal to 1 million. So this is how you can make this. Only 7 likes to be with. So what I had to show was 7 and 143, but I had to keep it as 7 and 142.85. So what should I do with 7 and 142.85? This is what I have to show you. So here I saw that there were a few numbers called what only 7 likes to be with its best friend, 142,857. Just kidding. So 7 only likes to be with 143, then 142,857,143, and then 142,857, 142,857, 143, and so on. So 7 only likes to be with them. Multiply one of these 3 numbers by 7 and you will get 2 ones on the sides with zeros surrounding them. So let me show you. Now 7 times 143 is 1001. Yes. So it kind of works with 142,857,143. Yes. So let me show you how it works. There, now I've chosen a number. Now I'm going to multiply by 101. Now what will this equal? 1 4 1 4 4 2 8 5 7 1 4 3. No, 42857. What? 42857. Yes, 42857 443. So now what I have to do is this thing minus So this 14 will become negative. So minus 14 plus 42857, 1443 is equal to 428571429. So this is how it works. It can also happen with 7 and its multiples. The only it can work with the factors of 1001. Also 7 is a factor of 1001, but this conjecture can only work with the factors of 1001. So if you like this video, don't forget to like and subscribe. Bye bye. Let me tell you 9 for fine. Okay, 9 for fine, what do you mean to say? Okay, so there are a few subtraction problems that are for using the multiples of 142,857. Also, you can make the sums. For example, the left hand 3 digits plus the right hand 3 digits is equal to the middle hand 3 digits. For example, there will always be a 999 in the middle of multiples of 7 multiplied by 142,857. Now let me check. Now there is a multiple 342,999,657. Okay, now there is one sum you can make. Okay, so I take the 342 and then I add the 657 and together they become 999. Yeah, this is what the sums are. Okay, so you get into hard sums like this, but even still, these type of sums are even good for a particular 9. Okay, so 9. So I've kept this 9 for fine because we are going to talk about 9s and 142,857. So okay, now let me tell you 142 and now 857. This can be done with the main number too, but there's some logic used. Also 142,857, that number is not going to just say that. Okay, so 142 and that 999. Okay, so that 999 we are going to do that 142 and 857. Okay, so what do they say? 999. Okay, so this was one specific term of the numbers itself. Okay, so to keep this 9 for fine, okay, now there should be between 142 and 857, there's some. Okay, so 999 gets to their sum. So which means 999, which is a multiple. Okay, so let me tell you how can I show you the 9s, because the 9s are very special. They can show anything here. Well, instead of 999,999 I took 999 itself. Now suppose instead, no, okay, now suppose I took 999 and now I multiplied it by 343. Then what will this answer become? 342,657. Okay, so there is one chance that even this number can appear. Now there can be a possibility that there were 3 nines between the 342 and the 657. So which means that 999 can solve the problem of this. 342,999,657. Yeah, this is one property that you have to remember. Okay. Now this is very easy. You can find it with the multiples of 999,999. Now suppose I took another number that is 418. That is 417582. Now this is one possibility. Okay. Now we cannot add 3 nines to that. Now since we can arrange the digits together, we get a proper number. That is 142,857. Now we cannot add 3 nines in middle. Now the mirror will become like 4, 2, 5. Yeah, I know. 5. Okay, so now if you want to multiply 142,857, now by the same number you get is equal to, yeah, I know it, 5771. No, not just. Okay. 59714826. Yeah, this is the correct number. Possibility is that these two numbers, okay, so 999 and 142,857, their one of the chance is the same. Just take any number and 142,857 will use its digits. Now take 267. Now this will become 266,733. Now take 267 and this will become 38142819. Well, there are chances that it cannot use the digits. Also, let me tell you a few parts of that. It can be changed into subsequences and done. Your answer of 999. Okay, now 814 plus 128. That's going to be 942. No, that's not going to work. If you want to take the, okay, Okay, so now take 38, then 142 and 819. Yeah. Now just take the sum of both of those two numbers. 266 plus 733, then 38 plus 142 plus 819. They both equal 999. See? Also, two parts of this cyclic number also equal 999,999. One last example and I'm going to end the video. Okay, 999 times 738. That's going to be 733, not 737. Okay, 737, 737, 262. Okay, now this is going to 105. Okay, 105 428566. No, 428466 I meant to say. Okay, now this is correct. Now just add the two parts and three parts together. So 737 plus 262, 105 plus 428 plus 466, and they are going to equal 999. Okay, so was this really successful? Okay, so were you successful in doing this thing? So if you liked this video, please don't forget to like and subscribe. Bye bye. Have you ever heard of these three columns: 0, 143, and 857? Okay, so 0 goes to remainder 0, 143 goes to remainder 3, remainder 5, and remainder 6. And 857 goes to remainder 1, remainder 2, and remainder 4. Okay, so these are the first few terms of this thingy. Now let me show you how can I express these things with all these things. Now since 142,857 is the 100th term of this sequence, let me show you how to find the 200th term, the 300th term, and so on. Now to this, let me find 100 cubed, which is 1 million, and 1 million, and now I copy this number down here, 1 million. Now minus 1, which is 999,999, then divide this whole thing by 7 to get 142,857. Yes, this is a part of this sequence. What I needed to show you was this. Okay, so look at this number very carefully. Next things next, what I have to do is, in this term, in this sequence, 142,857 is the 100th term, then 1,142,857, then 3,857,143, then 9,142,857, then 17,857,143, then 30,857,143, and so on. So 142,857 is popular for this thing as 142,857 and 857,143, they equal 1 million together. Now let me demonstrate you to a table. Okay, so there is a table coming later for you. Okay, so let me demonstrate it. So this is the term number n times, okay, now let me say n divided by 7. Now n times 10 divided by 7. And now n times 10 squared divided by 7. Now let me make this column a little bigger. And now n times 10 cubed divided by 7. Now this is term 0, so this will be all zeros. If this is term 1, then this is 0, 143, 142,857, and 142,857, 143. Now this is term 2, so term 2 will go to 1. And this will, and the 20th term, then this goes upon the 200th term, and this is the 2000th term. Then this is term 3 is 4, then 3857. This is term 30. This is term 300, and this one is term 3000. And goes to term 4 is 9, and 9 is basically going to term 40, and this one goes to term 400, and this one goes to term 4000. And for the term number 5, this is term 5, this is term 50, then this one is term 500, then this one is term 5000, this is term 6, term 60, term 600. All you have to know about these things, and this one is term 6000. Okay, so all you have to do is practice to learn about these things. Okay, so there is an infinite table of this all the way n times 10 to the infinity divided by 7. All this for the numerator will always be 7. Okay, so if you liked this video, please don't forget to like and subscribe. Bye-bye. Okay, do you know what is 1 divided by 7 times 2 to the power of n? Now suppose 1 divided by 7. Okay, so all these multiples appear. Now 1 divided by 7 goes to a 0.142857, so on. 1 divided by 14, 0.0714285. 1 divided by 28, 0.035714228. Now 1 divided by 56 goes to 0.017857142, so on. 1 divided by 112, this goes to 0.08938571428. No, not 8928, 8928. then the next thing is 1 divided by 224. You will see 0.04464285714. And now when it goes to 1 divided by 448, that goes to 0.02232142857. And now 1 divided by 896, this goes to 0.01160714285, so on. Okay, now here are the following problems for this day. And now let me tell you something about the numbers, about like these. 1 divided by 7 times 2 to the power of n. Okay, so what it has the quality is that it goes to the remaining multiples of 142,857. Okay, so this is known as recurring multiples of 142,857. Okay, this is also the same thing with 76,923, but I'm going to make another video of that, okay? So do not grieve. Okay, so what did you see in this thing? Yeah. Okay, so you get these multiples. When you multiply 142,857 by a power of 5. Okay, so here's 142,857 itself, then 714,285, 3,571,425, 17,857,125, then 89385,625. No, 89285,625. Why do I always remember a 3 in my mind? You have 4464 28125. Then next 2232 140625. Then next 1116 703,125. Well, these are all multiples of 142,857. They are all multiplied by a power of 5. Yeah, and when you add this together, 571,428. 857,142 and 285714. 428571. Then original number 142857 itself, and this goes to 714285. Okay, so this demonstrates all the 6 multiples of 142,857. Okay, so now that I have space, let me just extend it. Okay. Okay, so this space goes to okay. Okay, so I'm not going to pay attention on this too. Okay. Since these two are less than 7, but I want numbers which are greater than 7. So, well, these multiples are less than 7, but I want something greater than 7. Okay, so this goes to 571,428. Then I remember it. I really remember it. Okay, so this is multiplied by 625. This goes to multiplied by 3,125. Then this whole number is multiplied by 15,625. Then this number is multiplied by 78,125. Yeah. Okay. Now to get the next number, it's going to be 5555803515625. Okay, this is going to lead us to another 571,428. And then 2790 no 27917578125. Okay, is this number right? Well, by the way, okay, so this is really a loop, goes to 857,142. This really goes to a loop until you end at 714,285. Now if you do it with bigger multiples, then it's not going to work for you. So if you really like this video, please don't forget to like and subscribe. Bye bye. I want you to take a multiple of 7 and multiply it by 142,857. So let me just tell you multiples of 7 multiplied by 142,857. Well, the two things I like in these type of maths are multiplication and division. That's it. Because addition and subtraction I already know. Well, I gave you something like subtraction in chapter 3. You can watch its video in the description below. So let me just say, now take any multiple of 7. Okay, so now what did it say? 959. Yes. Okay, now just multiply it by 142,857. Now what is this number? 136,999,863. Yeah, this is the number that I wanted to show you. Okay, well, by the way, if you delete any two of these numbers 9s, then this will become the number that appears in the reciprocal of 73 infinitely. So now let's get back into the topic. Now now that I did this, now let me rub this, and now let me do another problem. Well, let me store this number here in the very right corner. 136,999,863. Now even if you say that now 959 is a multiple of 7, even if you divide by 7, this will become 137. But now this number, now what we are talking about, I'm talking about since. Okay, so let me bring this number back at the top. Okay, so now remove the 9s here. Okay, so we are doing this along with 999. And now 136,863 now divided by 137. Now what you get is 999. Yeah. Now since 959 is a multiple of 137, I divided. But sorry, I made a mistake here. In the next problem, I'll not make a mistake, even a single. Okay, so there's a test I want to give to you. Okay, so first multiply 142,857 by 721, and now just reveal the answer and what you get as for 999. And remove the 9s at the middle, and you just have to take if your number is there, if your number is practically divided by 7. Okay, here's your test, and your time starts now. You will do this in 25 seconds. Tick, 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 tick. Okay, so I'll reveal the answer to you. Okay, so this is the problem. And now just remove, did I do the equation wrong? Wait, 99 plus 2 is 1, how 1 is that? Oh, looks like I didn't do the equation wrongly. Okay. Now since you got this answer, now what you have to do is, well, finally now I got the answer for you. Okay, so 102, 999 and 897. Okay, so I'm going to give you one last answer and you will do it on your own. Okay, so 102, 897. I shouldn't have divided by the number itself. I should have divided by 999. 1. Okay, so divided by 999. 103. Okay, so this is the final answer you will reveal. Now, since 721 is a multiple of 103, that's okay. So you get a single multiple of 103. You have to deal. You get a single multiple of this. Okay, so whatever answer you divide by 999 will get you for that number, and that will be divided by 7, right? Okay, deal with those nines in this question. Deal with those nines in this property. That is not even, well, the next question, the next and final question I want to show you is that now just take a multiple of 7 and now multiply it by 142,857. Remove the 9s at the middle, then divide by 999 and you will get that number, multiple of 7 that has been divided by 7. Yeah, these are the steps. So by the way, here's the final step. Okay, now take 142,857 and multiply it by 553. Then what do you get? 789999921. Okay, so this is the middle of those nines. Okay, so now this became 78,921. Now if you divide it by 999, now if you rub those nines here, that became 78,921. Now if you divided this by 999, it became 79. Okay, so these are the steps you have to reveal, and you have to remember this type of steps in your mind. Okay, so I used 999 in this, since it's a part of the multiple of 142,857. So if you like this video, please do subscribe to my channel. Don't forget to like and subscribe. Bye bye. Let me take 43 as an example. Now 43 divided by 7 is 6.142857, 142,857, and so on. Okay, so here's one thing I want to tell you about this. Okay, so dividing a number by 7 from the multiples of 142,857, I mean, just multiply that number by 142,857. For example, now I gave you the number 43, so 142,857 times 43 is 6,142,851. And now what I gave you was 43 divided by 7. That was that 6.142857, 142,857, 142,857, and so on. Okay, so what I have to do is take this part, okay, so in this manner it will repeat multiples of 142,857 as a pattern. Okay, now I chose the first 142,857. Now just keep this 6 in your mind, And next, what I have to do, 142,857, and that minus 6 is equal to 142,851. So see, this trick is never ever going to happen with the multiples of 7. Well, for the sake of this video, let me show you how do I do that. Just one more chapter and I'll make a playlist of all of these. Now let me tell you, how do I divide a number by 7 from the multiples of 142,857? Now here's a thing. Now, for the sake of this video, I want to tell you a number, 91. Now take 142,857, multiply it by 91. What does it say? 12999987. Now this number is what you get. Now, what is the next thing you have to do is, okay, this is really easy since it does not happen with rest other numbers, because now the earlier trick that I showed you, 91 divided by 7 is what? 13. Well, now since for the sake of this video, I'm going to keep as 12.99999999999 and so on. Well, now 91 divided by 7 is 13, but for the sake of this video, I did it. Okay, so there's one trick that you have to receive. Okay, so 999,999. Now just keep this number 12 in your mind. I made a mistake. Yeah, I really made a mistake. It would happen with the multiples of 7. Because I was thinking it will never happen with a multiple of 7 since they get a remainder 0, right? But I made a mistake. So just keep this 12 in your mind. And now 12.999999. Now take this 99999 and subtract 12. Now what do you get? 999987. Okay, so concatenate that. Well, actually, guys, I made a very big mistake. But since now, I'm going to keep that. 91 divided by 7 is 13. I thought it was never going to happen with the multiples of 7. But you can actually do now, since if there is a 6-digit number separating them. Okay, so the highest point you can reach is that, what do they say, 3, 4, no. What is the highest point? Yeah, the highest point is 350,000 for this. Now if you say that 350,001, now what to say? 5000. Sorry guys, I didn't know what is the highest value of what do they call, yeah, what should I call this? Wait, I forgot what is the highest value. I'll find on Google and then tell you in the description. So if you like this video, please don't forget to like and subscribe. Bye bye. Last chapter, and let me tell you what is the reason behind it. Okay, so I'm making 14 chapters for this video. Now since now I've did the chapter 14, I'm doing the chapter 14. I did chapter 2, chapter 8, chapter 5, and chapter 7. How funny, right? Okay, so let me tell you the interesting patterns of 142,857. This is one more playing with 9. Yes, because there are a few reasons between 142,857 and so many 9s. Okay, so let's say that now like 15. Okay, so take any digit, start from the leftmost digits and then multiply them by 999,999. Well, here's a test. 2 times 999,999. That's 1,999,998. Then what? 15 times the same number again. 14,999,985. Then the next thing, 143 times the next thing. Okay, so from this pattern, I can understand that the last and first, they are making their own patterns. Okay, and next 1,429 and times the same thing. 1428 998571. Okay, they're beginning with the same thing. Okay, now I'm going to do a very simple crossword on this thing. Then 14286 times this 999,999. That is 14285 99857. Oh no, 14285 985714. Then 142858, and now times this number. Now this becomes 14285685714 857,143. Okay, so there is all these integers, they are decreasing by 1. No, increasing by 1. Now I increased any one of their digits. Now I just placed the 100,000s digit. Then now I added first the 100,000s digit together. Next I added it with the 10,000s digits. Then next I added both of them with the thousands digit, and then I added all of them with the hundreds digit, and then for the tens digit and the units digit. So this is how they are allowed to use. Okay, so one beautiful pattern is that even the 142856 and 857,143, yay. What but now what are your regards about this beautiful pattern? Okay, so here's the pattern. Here's a hint. They equal the number which is the same just as it was. Okay. Hint is you have to add them together. So 142,857, and now plus that 857,143, that becomes 999,999. See, that's just one tricky mind. Even if you want to still continue over, then just 1428572 1428572 times the 999,999. Boy, this is very tricky. So this is one interesting pattern. Okay, so you really like this video? So if you like this video, don't forget to like and subscribe. Bye bye.